Hello and welcome back to the video series about manifolds. As promised, today in part 16 we will talk about smooth maps between manifolds. Indeed, this is what we need to formulate the regular value theorem in the general case. However, as always, before we start with this, I really want to thank all the nice people who support the channel on Steady via PayPal or by other means. And please don't forget, as a supporter, you have early access to all the videos, you can download the PDF versions of the videos and do some quizzes for them. Okay, and then I would say we can start with the topic of today, which is about smooth maps. So what we need to define this new concept are just two smooth manifolds, and the one we can call M and the other one N. And then, without any problems, we can define maps between these manifolds. And now the notion continuous makes immediately sense for such a map because we have topological spaces left and right. However, this also means that the notion differentiable does not make sense immediately. For example, you already know from real analysis that in order to define a derivative, we need to measure distances. But in general, we don't measure distances in topological spaces. Therefore, the question of today is, how are we still able to define the notion differentiable map between manifolds? And indeed, the quick answer for this question is that we can simply use the smooth structures we have on both sides. For this, please recall, for a smooth manifold, we have charts that can have an overlap. So here, let's call the one chart H and the other one H tilde. Okay, and now you know, for our smooth manifold here, we have transition maps on the lower level, and all these transition maps between Rn and Rn are diffeomorphisms. In other words, differentiability here on this level makes totally sense. Okay, now obviously we can do the same on the other side, and there let's call the charts K and K tilde. Also here we find transition maps, and there are also diffeomorphisms. Moreover, now you should see that we can translate this map here, this abstract map F, into a very concrete map between Rn and Rn. So for example, we could simply go from here to here. Now, this is not just a map F, but a composition out of three maps. So first we have H inverse, then F, and lastly K. Now, this is a new map defined on a subset of Rn into Rn again. Therefore, for this map it now makes sense to ask, is this map differentiable? And here, please recall, differentiable is always a pointwise property. In other words, we can fix a point here on the manifold that is then translated to Rn here. Hence, it should be possible to define the differentiability of the map F at this given point by translating it to the lower level and ask the differentiability question there. However, then another question arises, is this answer for the differentiability here on the lower level dependent on the given chart? Or to say it in other words, what changes when we go here to another map which is given by H tilde? So does the answer for the differentiability change here? And we can immediately say, no, it's independent because of our transition maps. So we know the transition maps are differentiable in both directions, so we can simply change the map we consider here without changing the differentiability. So there you see, the smooth structure goes into the definition of a smooth map here, which is a very abstract concept. Okay, then I would say, let's formulate this with a formal definition. And maybe here, let's immediately formulate the definition for C infinity smooth manifolds. So M and N should be C infinity smooth manifolds, and you know this is our highest smoothness level we have defined in part 12. Okay, and now we consider the abstract map F between M and N. And now the notion we want to define is given as differentiable at a given point P in M. And indeed, if we want higher differentiability, we can immediately put that into the definition and say it's K times differentiable. And you might already guess, often we will deal with C infinity maps. Okay, and now in order to define it, we just need a chart on the left hand side and a chart on the right hand side. Moreover, of course, what we also need is that the point P lies in U, so in the chart on the left hand side, and the image of P, f of P, lies in W in a chart on the right hand side. So there we have our assumptions, and then we can consider this new map here between Rn and Rn. More precisely, we would restrict this map to suitable subsets in Rn. However, this is just a technical detail. The important part for us is that this map now is k times differentiable at the given point h of P. Or in other words, if we have this, then we can call the abstract map f k times differentiable at the point P in M. Okay, and now by our discussion above, you already know if this works for two given charts here, it also works for all other possible combinations of charts. Moreover, you should also see we can stretch this definition to a plane k times differentiable if it's k times differentiable at all points P in M. And indeed, this will be the definition we use most of the time. In addition, you also know the best case scenario would be that we have infinitely many derivatives, and this is what we call C infinity smooth. In fact, a lot of authors just say smooth when they mean C infinity smooth. Okay, and now this means that our function f is k times differentiable at the point P in M for every point P in M and for every natural number k. So in short, f is differentiable at all points, arbitrarily often. In addition, we also have a nice notation for such functions. We simply write f is an element of C infinity M. And if the codomain is not clear at all, we also have to put that in, so we write comma n. However, often the codomain will be simply the real number line r, and then we will omit it here. Okay, now later we will talk more about the structure of this special set here, but first we should talk about examples of smooth maps. However, this might be more fitting for a separate video. Therefore, I really hope that I see you in the next video and have a nice day. Bye!